Hello everybody and welcome to this new tutorial of OpenFOAM. Today we're gonna work on dam break problem. So here is our test case. So we have this domain, we have water column, and the remaining domain is constituted by air. And when we are supposing that we're gonna have a break of a dam, and we're gonna follow how the water will be dispersed in the domain when it hits this obstacle. So this is the problem we're gonna work on today. So I'll mention this link in the description box in order to for you to get track on, and also you have too much information, you can go here, table of contents. So here it's version 8, it depends on your version, but for the breaking of dam it's a standard tutorial, so we gonna find literally the same files. So you can browse the table of contents. So here you can find all the tutorials available: cavity, stress analysis, breaking of dam, and other cases, tips, how to post-process, mesh generation, mapping, and a lot of things that can be useful to learn OpenFOAM. So let's go to our case, which is dam break. So I created an empty folder here. This will be my work directory. So I'll open in terminal and I'll go to tutorial by typing TUT. So here I am in the folder of tutorials in my version. So my version is OpenFOAM dev. You can work with your version 8, 7, 6, or whatever is your version. So just to follow this tutorial, so we will go in foam tutorials, multi-phase, interFoam, laminar, dam break. I'll open this folder. So it's CD, multi-phase, interFoam, laminar, dam break again, or I'll just keep it like this. So ls, I have here, you can see that I have my test case dam break. So I'll copy this folder to my work directory. So I'll make cpr dam break to my work directory, so it's home. And here it is. So let's check. Here we have the dam break. We have here an all run file. So here we can find the commands that we have to run in order to get results for this case. So we'll start with block mesh, set fields, and then the application. The application is the name of the solver, so it will be in our case interFoam. So I'll go step by step with this test case. So let's start with block mesh in order to get the mesh. So it's located in system folder, block mesh dict, and here we have our domain. I'll make it like this, and here you can see that we have the coordinates of the vertices. So here I have vertices and I have blocks. How many blocks do we have here? We have 5 blocks. So what we will do, I will do a screenshot of this domain, and I'll split it on 5 blocks in order to explain in details how the vertices are assigned using block mesh dicts, and also here we don't have the same coordinates, so we have to modify these vertices. So I'll explain step by step how does it work in block mesh dict to generate vertices and also to define your blocks. So here I'll screenshot. I'll select an area to grab. So I name it dam break domain. And I'll check here. So here we have our domain. So I'll open it with open with other application and color paint. Okay, so here we have our domain, and I'll go with it step by step. So for the blocks, here we have an obstacle. So I'll draw the lines. I'll draw it with the blue color. So from here to here, we will have the first block. So the principle of block mesh dict is to divide your domain into rectangular blocks, so it will be easy to generate the mesh. So our domain is this, so we will generate blocks, rectangular blocks. So this will be first block, second block, and here. Okay, and I'll mention here for example block so I'll mention here for example block 1, and this one will be block 2, this one will be block 3, this one will be block 4, and the biggest one, the other one, will be block 5. And now we have our blocks. We need to name vertices. So we need to go 0, 1, 2, 3. How many vertices do we have here to constitute our blocks? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, and then in the other, as you know, in OpenFOAM we have all the geometries generated using 3D. So we have it's mandatory to use 2 faces. So we have this face at, let's say at z equal to 0, and the other face will be at z equal to 1, for example. So we have 2 faces with the same organization of vertices. So we count until 11, so we will start again in the other face with 12, 13, 14, 15, 16, 17, 18, 19, and then 20, 21, 22, and 23. So I hope it's clear in your mind. I'll draw it also to make it clear. So it's like we have a domain like this. I hope it's clear. So this is the face I'm talking about for the other vertices. So here we have the first vertex which is 0. Okay, I'll make it here 0. Here it's 1. This vertex is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here again in the other face I'll write it in green. And 11, so in the this face at z equal to 1, for example, it's the vertex 12. Here it will be the vertex, the vertex 13. Here it's 14. Here 15, 16, 17, 18, 19, 20, 21, 22, and 23. So here are our vertices. So I'll start block. So we will assign at first before doing blocks, I'll do vertices. I'll assign the vertices. So for the first, this face, for the face with the vertices colored in red, so it's at z equal to 0. So our vertices will be, the first point is 0, starting with 0, 0, 0, and I'll comment it with vertex 1. Okay, then the second vertex is this one. Sorry, this is vertex 0. And for 1 it will be 0.1461 plus. So this will be the total distance. Okay, so I'll use a calculator to sum up. It's 0.1461 plus 0.1459, and it's 0.292. And for y it's equal to 0, so I'll plot it as well. So here I'll color it in purple. So we're starting, so this is the x and this is the y. This is x and this is y. Okay, so let's continue our vertices. So this point, for this vertex we have x equal to 0, 292, and for y is equal to 0, and for z equal to 0, and this is vertex 1. The third point, which is vertex 2, so we have to sum up this with this distance in order to get this the x value of this vertex. So I need to sum up 0.1461 plus 0.1459 plus the value of this distance is 0.024. So it's 0.024 and then it's 316, sorry. So I'll copy it. This will be this vertex for y equal to 0 and z equal to 0, and this will be our vertex number 2. For vertex number 3, so number 3 is x equal to 0, it's here 584. So it's 584, y equal to 0 and z equal to 0. This is vertex 3. Okay, great. Then we have this vertex 4. So this vertex 4, we have this distance of y. We have x equal to 0 at first. And then we have y equal to 0.048. So it's this distance. Then 0 vertex 4. So I hope the principle of assigning values or coordinates for each vertex is clear now. So I'll copy for the other vertex because it will be the same with changing only the y value. So for this one, 0.048 in y, and this will be vertex 5, just to make things really speedily, just to make things really quickly. So this will be vertex 6 and this 7. Okay, so it's okay for all the vertices in this line. Now we have 8, 9, 10 and 11. We have this line. So we will have the y value will be equal to 584, and for the x value will be copied from the previous vertices. So I'll copy this one. Okay, I'll keep the I'll keep the x coordinate, and for the y I'll change it by 584, and I'll copy it for all the other coordinates. And here of course I should change the number of the vertex. So it's vertex 10, 11, sorry, it's yes, I missed the 8, 8, 9, 10 and 11. This is for z equal to 0. Now for the other face at z equal to 0.1. So I'll copy the same, because actually it's the same organization, it's the same order. The only difference is in the z coordinate. So I'll replace the z coordinate in all the points with 0.1, 0.1, 0.1, 0.1, Okay, and for the numbers of vertices, it's here 12, 13, 14, and so on. So here we have the vertices of our domain. So I will not here if you want to convert to meters, for example, you when using this value, all the coordinates will be multiplied with this value. So here we don't need it, since we introduced the real coordinates from the domain to our block mesh dict. You can use it in some cases when you want to modify the scale, for example, of a domain or something like this. But in our case, we introduce the coordinates as it is in the domain, so we don't need to convert to meters. So I'll make it equal to 1. Okay, and here for the previous, I can delete this, the old vertices. So now we have the blocks. We have for the first block, so the block, we have to see it as 6 faces. So it's not this only face that you see it here. You should consider it as in 3D format. So for block 1, for example, you should consider this block. This is the block 1. So you should consider the face at z equal to 0, 1. So for block 1, we have the points 0, 1, 5, 4, and then the other face is 12, 13, 17, 16. For the second block, this block 2, we have 2, 3, 7, 6, and we have 14, 15, 19, and 18. For the block 3, we have 4, 5, 9, 8, and again we have 16, 17, 21, 20. Okay, and for this block in the middle is 5, 6, 10, 9, 17, 18, 22, 21. Okay, and for the last block, the block 5, we have 6, 7, 11, 10, we have 18, 19, 23, 22. So I think it's clear. So now we need to grade our blocks. So as a first step, let's keep this grading and we will visualize it. If it's okay, we will keep it as it is. If it's not okay, we're gonna refine it and change it. Okay, just now we need to run block mesh in our folder. So here I'll open a new terminal and then I'll run block mesh. So it's okay for the block mesh. We can visualize it using OpenFOAM. So here we have the geometry. It's okay for our geometry. It's good. We don't have problems. And we need to visualize the mesh as well. So for the mesh, yes, it's acceptable. It must be good for our calculation. So we will work on it like it is. For the moment, we will keep it like this and we will try to set up our simulation. So here we have, I'll rerun it again. So here we have the I'll visualize boundary by boundary. So this is the atmosphere. This is the left wall. This is the lower wall. The right wall. The internal mesh, it includes all the faces, and for the empty, okay, for the empty group, it represents the face at z equal to 0 and at z equal to 0, 1, and it's assigned empty. Also here we have left wall, right wall, lower wall, atmosphere, and for the other boundaries it's empty because we have we want to simulate our domain in 2D, but OpenFOAM does not accept or support the 2D, so it's mandatory to include another face and consider that we have one cell, partition of one cell in the Z direction. So this is the idea. And now what we have to do, we will go here into velocity, and here we have no velocity in the for the internal field, so we have apply. So here we have in the left value, the left wall, the right wall, the lower wall, we only have the condition of no slip of the flow in the velocity of these boundaries. In atmosphere we have the type of pressure inlet outlet velocity, so the velocity in the atmosphere will depend on the pressure that we have in our domain. And in default faces, and this one and the other one will be empty. And for the pressure, for the pressure we have fixed flux pressure in left, right, and lower walls, and atmosphere is total pressure. And for alpha water, as I said before, we have here a domain, and we will have here a column of water. So interFoam, the solver interFoam, it works on the alpha of water, the volume fraction of water in this case, but you may have other fluid. In this case it's alpha water, and the other fraction will be calculated by using 1 minus alpha of water. So in the left wall, right wall, lower wall, it's 0 gradient, and in the atmosphere is inlet outlet, so it will depend on, it's like a discharge in the atmosphere. So the alpha water will depend on what is happening in the domain. But here you can see here, if I'm visualizing alpha water like here, so here we don't have any water because we have alpha water here is equal to 0 in all the domain. So what we need to do first is to define this zone as filled with water. So to do so, this zone must be filled with water to constitute water column. So what we need to do is to go to dump break. In system we have a file called set fields dict, and we will define a box. So here we have this box. So this box, we have the box from 0, 0, minus 1 to 1. So here we are including, you can see that we are including more than what we have in our domain, just to make sure this doesn't impact the problem. You can, for example, I comment it here, our z coordinate goes from 0 to 0.1, but here we are using z going from -1 to 1. Actually, it doesn't impact our domain because the rest of the domain will be empty when going up to values bigger than 0 and values smaller than 0 and bigger than 0.1. So this is the idea. For x, it's 0, 0, 0. Here it's for x it's 0 and y 0, so it's this point, and to x equal to x, it's here, equal to 0, 1461, which is here, and y equal to 0.292. So now we define the box. We have this box. We need to fill it with water. So what we need to do is to tell to OpenFOAM this zone will be filled with water. So the alpha water in this column will be equal to 1. So we are mentioning field value, vol scalar field value, alpha water. So this variable alpha water will be equal to 1 in this zone that we defined as box. So this is how we make it. So I'll close bar view and I'll run set fields. In order to execute this, what is written in this file, we need to run the command set fields. Okay, so it's done. So let's see in OpenFOAM now what is happening. Apply alpha water. So here we have our column assigned here. So in all our domain. Okay, and the last step here. So we saw the boundary conditions here. So you will see that we have a new alpha.water created in the 0 folder. So I'll open it. Is not text editor is not responding. Why? Because the created alpha.water, the new file, is created in binary format. So I'll show you how to solve this problem. So I'll force it to quit. I'll go to system, control dict, and here we have right format binary, and I'll modify it to this format. So now I'll delete this file and I'll generate it again in order to generate another file. So here we have our file. So we have 01, you will see just 01, 01, 01. So this is like OpenFOAM is giving numbers for each cell, and each cell here I'll show you in OpenFOAM. Okay, so OpenFOAM here, surface with edge and alpha water. So for each cell here, the number of each cell, so each cell here, it will assign for this one, for example, 1 1 1 1 1, and when it's in this cell it will assign 0 0 0 0. So this is how it's done in alpha water. But in the bottom it will keep the conditions for the boundaries. So for the left wall that we've already explained in alpha water dot original here. So here in constant we have the gravity. So here we have the y direction. So the gravity will be minus the direction of y. So this is why we have minus 9.81. So the simulation will be laminar. We don't have turbulence. And in transport properties, we are introducing the properties of water, transport model, viscosity, and rho, the density. And also for air, we have the viscosity, the density equal to 1, and the superficial tension, which is sigma between two phases, is equal to 0.07. And in system, we saw block mesh, set fields, control dict. Here we have the solver, start from, and all the other parameters. The compose predict, it concerns the parallel computing and the schemes of the simulation, the solution solvers and tolerances. So this is all these are all the files that we have in this case. So now I will run the solver, interFoam. So it's done. It's very quick. So foam. Okay, apply alpha water here. So you see here we have the water column at time equal to 0. We are supposing like this this dam is breaking, and then the water will go and hit this obstacle, and what happens when it hits the obstacle? It goes up. So this is it. So here you can see that we have bigger pixels. Just need to refine the mesh in order to get smooth view of this. Okay, so you can visualize this in this way. Okay, you can also save an animation. Save animation. I'll name it animation. Okay, so the quality. Okay, for the background I want to make white background. Okay, here I have the animation. So it's very slow. It goes step by step. We can do other thing in order to speed up our animation. Save animation. I'll name it B. Okay, and for frame rate, for example, I'll make 3, so it will take only one frame each 3 frames. Okay. Oh, let's see. B. So this is quicker. Okay, so that's all for the tutorial of today. Hope it's clear, and don't hesitate to leave a comment if you have a question about this tutorial, and see you next time.